Hello friends, welcome to studyandsign.com. In this video, we will review the concept of Otto cycle you need to cover for exams. Let's begin. So first, we will understand what an Otto cycle is. The cycle is also called as constant volume cycle, and we will limit our discussion to ideal cycle only. And this is the basic thermodynamic cycle of spark ignition reciprocating engines. The basic cycle was discovered in 1876 that Dr. Nicholas A. Otto developed the first successful four-stroke spark ignition engine. And as we know today, spark ignition engines are very widely used in automobile, and which is why it is important for us to understand the basic thermodynamic cycle of spark ignition engine. Moreover, the Otto cycle can be implemented in 2 or 4-stroke engines. Now, let's look at the processes of Otto cycle. The cycle basically consists of 4 processes. It begins with an isentropic compression process, and then there is an isogoric or constant volume heat addition process, followed by an isentropic expansion process, and ends with a constant volume heat rejection process. And all these 4 processes are internally reversible. Now, let's look at the ideal Otto cycle in terms of PV and TS coordinates. I mentioned that Otto cycle consists of 4 processes. It starts with an isentropic compression. So on the PV diagram, you can see process 1 to 2 is isentropic compression process. Heat is supplied to the engine at a constant volume process 2 to 3. It is followed by isentropic expansion process 3 to 4. And heat is rejected at a constant volume process 4 to 1. Now let's look at the same processes on TS diagram. First process is isentropic compression, which is why you have a vertical line 1 to 2, constant entropy. 2 to 3 is constant volume heat addition process. Heat is supplied during this process 2 to 3. And isentropic expansion process 3 to 4 is vertical line, constant entropy. And process 4 to 1 is constant volume heat rejection. Now from the PV diagram, compression ratio R is equal to V1 by V2, which is equal to V4 by V3. Now we shall apply the energy equation for this cycle and find out the heat and work interactions, which will basically give the expression for the efficiency of an Otto cycle. And now the heat is transferred from the working fluid. Qs is taking place during the constant volume process between state 2 and 3. Therefore, Qs is U3 minus U2, which is constant volume, and therefore Qs is equal to Cv times T3 minus T2. Similarly, heat is rejected by constant volume process 4 to 1, which is U4 minus U1 and is equal to Cv times T4 minus T1. Therefore, thermal efficiency of an ideal Otto cycle with the cold air standard assumption is basically W by Qs, which is 1 minus Qr by Qs. Substituting Qr and Qs, we get eta Otto is equal to 1 minus T4 minus T1 divided by T3 minus T2, and is equal to 1 minus T1 by T2, and which is equal to 1 minus T4 by T3. From process 1 to 2 and 3 to 4, from TV relation TV raised gamma minus 1 equal to constant, we get T2 by T1 equal to V1 by V2 power gamma minus 1, and is equal to V4 by V3 power gamma minus 1, which is equal to T3 by T4. and is equal to R power gamma minus 1. Substituting this value in the efficiency expression, we get eta Otto is equal to 1 minus 1 divided by r power gamma minus 1. Now let's look at some important points to remember. Point 1. As the compression ratio R increases, efficiency increases. Point 2. Limit of compression ratio is subject to knocking phenomenon in spark ignition engine. Point 3. For SI engine, the compression ratio varies from 6 to 10. If better fuel is available, we can employ Otto cycle for compression ratio more than 12. Point 4. For maximum specific output of a constant volume cycle, temperature of the working fluid at the end of compression T2 and expansion T4 should be equal. That is T2 equal to T4, which is equal to root of T1 into T3. And now we look at the expression of mean effective pressure. Mean effective pressure is defined as the ratio of work done to stroke volume. And this is the expression of mean effective pressure of Otto cycle, where K is the pressure ratio, R is the compression ratio, and gamma is the ratio of specific heat. And so I thank you for watching this video, and please study the concept explained in this video and also practice multiple choice question with the help of our other videos. It will be very useful to shine in your exams. Thank you. Thank you very much.